Hello, my name is Nicholas Jones, and I'm going to be talking about the contributions of the Chinese to the history of math today. I am doing this for my lovely history of math class. Well, let's start off by saying that the Chinese, their first number system was just like ours and was a decimal system, and it was from 0 to 10. They used number rods, and from 0 to 4 it was just almost like a Roman numeral, and then when it got to 6 it was almost like an upside down T like this, and they would start adding to it to make it until it got up to 9 or 10. After that, then they would use these to do complicated actual solutions of addition, because they could take and say, well, if this part is a 10 or something like that, then I can move this over and add to it, and the combination of things would make numbers. Almost kind of like the way their language works, to where you can have something that looks like a H as mother, and then if you add something like this, I think it's mother with child, and then when you come off, you can take it off like this, and now it's child. A lot of their contributions are going to be something in number theory, just because they weren't people who made a lot of proofs. They weren't like the Greek culture where they were worried about rigorously proving something and doing it so well that they can find solutions and say, this is the answer, this is it, this is it. They were more like how the Greeks were in the field of geometry. They would attempt things and see if they could find solutions from them. If a problem arose in actual society, they would try to find a solution for it. A lot of problems, which are funny because if you read actual stories about it, it's like the 100 fowls problem. I have 100 fowls and I want to see how to divide them up. The sheep problem. Oh, I want to see how this divides out with these sheep. A lot of things they did were ironically not. Let's prove this and prove that it's 100% correct. It seems as if, though, that they actually had a lot of good solutions to things. The numeral thing, their actual numerals worked a lot like, if I get to the breaking point, then I will start using 9 times 100, that's 900, added to 5 times 50, and they could use their bamboo sticks to see this. They were one of the actual first cultures to use an abacus, and some people think that they were actually the culture that made the abacus or first used it. They had people who actually found solutions to Pythagoras' theorem isolated from Pythagorean. A couple people found pretty good solutions to pi. One of them actually found a solution of 3.1415, and he was correct to about 5 decimals out. Another one of them actually found a solution for it out to 8 decimal places, or he actually had 2 that he was going to pick from. And he was actually very, very close. And it's just ironic to see that, of course, because you would think in old times that there's nobody without calculators is going to be developing a solution for pi to 5 to 8 decimal places. And yet back then, of course, they did, because they had to do it and they wanted to, find solutions for it. The first guy who did out to 5, his name was Li Hu, I think is how you say it. And then the next person who did it, who actually got out to further decimal places, I think was Sun Tzu. But I could be wrong. It might actually have been, it was Zhu Chongzi, however you say it, Z-U, then space C-H-O-N-G-C-H-Z-H-I. As we all know, if you've taken any math class past, high school math, one of their biggest contributions was Chinese remainder theorem. So if you have something that's mod 3, something that's mod 5, and something that's mod 7, you have x1, x2, and x3. Using Chinese remainder theorem, you can take and find solutions for this. And it's a pretty simplistic idea, but it's pretty interesting, actually. I think one of the biggest things, because a lot of my research actually dropped down on this idea, was a textbook called The 9 Chapters. It was around 100 BC to 50 BC. Maybe even some people said that maybe it was perhaps in 200 BC. And it was within the Han Dynasty. It had 246 problems in 9 different chapters. And it definitely was the most longest surviving and most influential Chinese math book. And many people, even through the years, started doing commentaries on it because it was such a well-known book and such a influential math book. Of course, a lot of Chinese culture, they didn't get, until the Silk Road started coming through, they didn't get other math books and other idealisms. And even when they did, they kind of tried to neglect the other people's ideas because they wanted to keep with their own. So just as a breaking point of that, because there's some things and different things that Chinese culture had provided, but really I think this is one of the biggest ones. So chapter 1 had field measurements, a systematic discussion of algorithms. That's where they were using those counting rods, the bamboo sticks, and they tried to find common fractions. It actually almost boiled down to a greatest common divisor, a least common divisor. They could put them into shapes and find areas of planes. They could find the area of a square, a rectangle, a triangle, trapezoid, circle. They could find segments of circles. They could have spheres. Actual annulus. Some of them were accurate. Some of them were just approximations. A lot of them were approximations. In this book, they also had, and I think outside of this book too, Chinese culture had a funny way of explaining a point. It was something that had no end and was nothing. And yet lines had the ends that were nothing, that were points. Chapter 2 of this book, it was on proportions. They had proportional distribution. It talked about taxes because, of course, a lot of the Chinese, they were more worried about taxes than anything else. Chapter 4 is about widths, and with a given area or volume, find different sides, find different solutions to that. It found algorithms for the squares, for cube roots of things, and they used counting rods to find these computations. Chapter 5 was construction, so they found volumes of cubes, rectangles, rectangular parallelepiped. They found prisms, pyramids, triangle pyramids, a tetrahedron, which is surprising in, before Christ's time, a cylinder, a cone, etc., etc. They found approximations. Some of it, they used pi as just equaling 3, which is definitely not correct. Chapter 7 was where they found excess and deficiency of a square root. They talked about what's called a false position and double false position, so if you're over, under, etc. Chapter 8 was rectangular arrays. They gave eliminations for algorithms, solving systems of equations within 3 or more equations. It used negative numbers, and some people believe that actually Chinese people invented negative numbers for the idealism that in this book, and even in books of accounting, they would use red for positive numbers, and all of a sudden you would see these black numbers and they would be evening things out, and it was positive and negative numbers. It was just in its infancy. They used rules for sign numbers, so if you had something positive or negative, they had rules for that. Chapter 9 was right triangles and applications of Pythagorean theorem, even though they did not believe that that's what that was called. They had quadratic equations, solutions for those, square root algorithms. They found equations in the form of x squared plus ax equals b, where a and b were positive numbers. And it just seemed like this book really, affected all of history for Chinese history, because they just tried to stick with this book and make more and more solutions for it. And it's just intriguing that something so simple as this book, almost like Euclid's 13 chapters in his books about geometry and different things like that, and that was almost like their Euclid. And it's just interesting that that's the fact of what they really, were more so worried about, was this book, and making commentaries on it. Which I guess if you look at other people, such as Fermat, he made commentaries on Euclid's books, and I suppose every culture had their own certain Euclid or somebody who would, be the person who did that. Another person I kind of enjoyed was Li Hu, because he calculated the volume of a cylinder. He was the one who started out with the pi to 7 decimal places and calculating the volume of a sphere. And he kind of did this on his own, even though Archimedes had done this in Greek culture, I guess about 700 years before that. Qin Zhisho also was a pretty interesting person, because he could find solutions to equations of x squared plus 2x plus y squared, so basically like x plus y squared, and in cubic equations up to the third. Some of them he even found up to the 10th order, but he was not very proficient with it. And Euclid did this before that, but it just thought, that's interesting, They were finding things on their own. Qin Zhisho, he also brought the idea of zero back from India to China, and that was about the same time that it first reached Europe. A lot of things that went on with Chinese culture, it was kind of like influx of the Silk Road, and then also their interaction with Indian cultures. Quite interesting. A lot of their things were to deal with the calendar and astrology, and that was something that drove their math. A lot of their business stuff did too. One of their calendars they found, it was based on a cycle of 391 days and years, and that led to the further approximation of pi to 3.1415926, or perhaps between 3.1415927. And they actually, at that point in time, said a good approximation was 355 divided by 113. Or, if they wanted to use it, which is ironic because we use this still to this day, 22 over 7. I cannot think of what this was called, but they even had their own Pythagorean theorem, and they just called it something completely different. Can't think of it, but as we can see, it seemed like isolation for China was actually something fantastic, because they didn't have to worry about someone else's idealism. They pretty much only worried about their own, and because of that, they were able to make large jumps and finding things, and really all they were worried about was, how do I figure this out for the culture and for my answer. They had their own time frames when they were finding Pascal's triangle, like Yang Hu, I think was his name, found an actual solution to that. They had a lot of advancements in trigonometric things, like especially spherical geometry. They really were worried about astrology, so a lot of times they were trying to find answers to spherical geometry, or trigonometry, so then they could actually, find points in the stars and figure out when it was going to come back around. They thought of numbers almost as like a spiritual thing, and they tried to do these magic squares where every column and every row would add to the same number. one of the famous ones was where a 3x3 matrix, basically every column and every row added to 15. And because of these magic numbers, it led to magic squares, which eventually actually led to their own forms of matrices, which I found very interesting. They were one of the first cultures to actually find a solution for something with 4 unknowns and 5 equations, I believe. As we can really see, this kind of, shows the strength and the tradition of Chinese idealism, because of course they wanted to be their own culture, not be hung up on someone else's culture. And it was just quite interesting, to find things like that. I really wish I could remember the name of this thing for the Pythagorean theorem, just because I found that interesting, that a lot of things that we were crediting the Greeks with, there's so many other cultures, like Indian cultures, being able to solve a lot of algebraic equations, and then similarly people like the Chinese culture being able to solve algebraic equations. To have someone say, well, look, this is where they did it in another culture, and all this time that we credit it to them, maybe perhaps another culture was actually the ones who were maybe perhaps finding this. But I guess that's Western culture for you. Really, anything that was found in a different culture, they're going to basically say that it was us that figured it out. And I guess that's the benefit of being part of European and Western culture. But it's still very, very sad. We should be able to say that another culture aided in it. I do know that, since I'm talking about Pythagorean theorem, Liu, I think Liu's last name was Hugh, is how you say it. And he actually used Pythagorean theorem to find heights of buildings, which, if you go through a pre-calculus class, ironically, they always talk about that. They use a lot of circumscribed circles, or circumscribed polygons and circles, so they could approximate pi, which was pretty smart of them, because if pi is part of the circumference, and later on we figured that out, then of course that's something very, very smart. They figured out parts of Gaussian elimination, since I was talking about magic squares before, which was great. And they did it all by their lonesome, because they were isolated from other cultures. And this is bothering me that I can't think of that name of what this is. But we'll say that, since I'm talking about astrology and that they were worried about that, there's a Chinese word that said chouren, and it refers to both mathematicians and astronomers. And it shows you how really they thought an astronomer and a scientist and a mathematician was all pretty much the same. I think I finally figured it out. The Zobi Zhangjun, it contains a statement of what's called the Gogu rule or Goju rule, and that's the Chinese version of the Pythagorean theorem. They used it and applied it to surveying, astronomy, and other topics such as like the buildings that I was talking about. Maybe a square plot of land, they would try to figure out what was the diagonal of it. The only problem is that they think that maybe this is flawed because there was a guy named Needham who translated some of these things, and it could be a flawed translation. But it shows the pure tenacity of Chinese mathematicians. So really, as we can see, most of their stuff was actually accredited to more so number theory, but they were a pretty interesting culture. They found a lot of things on their own. They were isolated. They were surrounded by mountains, and yet they actually were able to come up with things on their own. They figured out solutions to things that they wanted to figure out. It was actually one of the 6 things that a Chinese gentleman needed to know, and that's really what started the idealism of you know, you need to learn this math and find solutions for things in actual modern day culture. One of the emperors actually made people go through, and other than like poetry, that was the thing they had to do, was they had to pass a math test to be a civil servant. Of course, a lot of it was kind of more so simplistic stuff, but then when you became a civil servant, you were expected to be able to figure out solutions to problems. If we're going to build something, you need to be the person to be able to figure out the math behind it, almost like an engineer. Once they started actually expanding, though, and even when they got conquered, they were able to keep their own culture. When they expanded, though, and some of the knowledge was coming through from the silk trade and the Silk Road, they actually were able to expand their knowledge and get a better understanding. So in closing, basically, they were an interesting culture. Chinese number theorem was probably their biggest contribution to modern day math, as I learned it in number theory, and I'm certain many people did in their undergrads. They were just a very interesting culture. I commend them for aiding to our history, and I wish that Western culture would give them more recognition. Well, I thank you for your time, and you guys have a good evening. Go check out some stuff about the Chinese culture and its contributions to mathematics. Thank you very much.